We are studying the second chapter, numbers and sequences. Today's topic is series. The sum of the terms of a sequence is called series. Very simple. Supposing these are the terms A, A1, A2, A3. So the sum A1 plus A2 plus A3 dot dot is called the series. If the series has finite number of terms, it is called a finite series. If it has infinite number of terms, it is called infinite series. In this exercise, we are going to do the arithmetic series, sums on arithmetic series. A series whose terms are in arithmetic progression is called arithmetic series. So you know, we studied about arithmetic progression in the previous exercise 2.5. We did so many sums on them. In this exercise, we are going to do arithmetic series, that is the sum of the first n terms of an arithmetic progression. Arithmetic progression will have terms. The sum of the first n terms of an arithmetic progression is given by these two formulas. If it is infinite, then we have to use this formula. Infinite means there will be dot 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 like this. That means Sn is equal to n upon 2a into 2a plus n minus 1 d. If it is a finite arithmetic progression, that means it will have a last term L. Okay, then we should use this formula. Sn is equal to n upon 2a plus L. Very simple. Let's go to the exercise. Exercise 2.6, question 1. Find the sum of the following. So this is an arithmetic progression. 3, 7, 11 up to 40 terms. First term is A. Let us find the common difference. 7 minus 3 is 4. That is the common difference. Number of terms is 40. N is equal to 40. Write down the formula. This is an infinite series. Dot dot dot. So you should write the first formula. So here write it down. Substitute these values. Simplify. You will get the answer. S40. That means sum of the first 40 terms. S40 is equal to 3240. Second sum. This is the arithmetic progression. N is equal to 27. This is also infinite. So you will use this formula. First term, write it down. A is equal to 102. Common difference D is 97 minus 102 minus 5. So substitute these values. Simplify. S27. They are asking us sum of the terms up to 27 terms. That will be 999. Third sum. So this is the arithmetic progression. These are the terms of the arithmetic progression. Here you can see we have the last term. Okay. So this is given to us. That is L. That is equal to 97. Common difference is 13 minus 6, 7. A is the first term. Okay. Now here we do not know the number of terms here. That is n we do not know. So let us first find out n. In this kind of sum, in this arithmetic progression with the last term, the formula for n is L minus A upon D plus 1. We did this sums in the last exercise 2.5. I hope you remember that. Okay. So this is the formula from the previous exercise. So use this formula and find the number of terms. You will get here 14. Then substitute n value here in this formula. Since it has a last term, we are going to use the second formula. Write down the formula. Substitute A, L, N, and you will get the answer 721. How many consecutive odd integers beginning with 5 will sum to 480? So let us first write down the sequence. Beginning with 5. So 5 is the first term. Then consecutive odd integer. Consecutive integer to 5 is 6. But we don't want 6 because it's even. We want odd. So let's go to the next 7. So after 5 comes 7. After 7, 9, 11, dot dot. So this is the arithmetic progression. Okay. So first term A is 5. Common difference is 7 minus 5. That is 2. That is the common difference. Now write down, and Sn, they've given the sum already. Sum is 418. We have to find n. How many integers are there? That is the terms. How many terms are there? N we have to find. So let's write down. Sn is equal to 480. So substitute A and D, leave n as it is, then simplify this. This will, on simplification, you will get this equation, quadratic equation. Split the middle term. We are using algebra here. Split it and you will get the value of n is equal to minus 24 or n is equal to 20. Okay. N, number of terms, cannot be negative. It has to be positive. So n is equal to 0 is the correct answer. Number of consecutive odd integers is 20. Find the sum of the first 28 terms of an AP whose nth term is 4n minus 3. So here the nth term, Tn, we know Tn, that means the term, nth term is given by 4n minus 3. We learnt about Tn in the previous exercise. So here it is, I've used it. Tn is equal to 4n minus 3. N, number of terms, 28 terms. N is equal to 28. Okay, let's find out the first term, T1. Substitute n is equal to 1. You'll get the first term, that is 1 itself. Okay, 4 into 1 minus 3 is 1. Second term is 5. So A is 1, D is the common difference, T2 minus T1, that is 4. Now very simple. Use Sn is equal to this formula. Substitute n is equal to 28 here. Simplify, you will get the answer as 1540. Question 4. The sum of the first n terms of a certain series is given as 2n square minus 3n. Show that the series is an AP. Okay. Let Tn, the nth term, be denoted as Tn. We want to find the formula for Tn. Okay, then only we can know the first term, because nothing is given to us. What is the first term? What is the common difference? We do not know. For that, we need the general formula for Tn so that we can find the first term and then we can find the common difference. After that, we can put the formula. Okay, so to write down Tn here, what we are going to see is what have they given to us. The sum of the first n terms is given by 2n square minus 3n. So this is the general formula for Sn. Okay. Now here the nth term is given by the sum of the first n terms minus the sum of the n minus 1 terms. Okay. To understand this better, how I can explain is, supposing supposing 5 is the fifth term. Okay. So I can say that 5, the fifth term, is equal to sum of the first 5 terms minus the sum of the first 4 terms will give us the fifth term. Okay. It's the same way. The sum of the first n terms minus the sum of the n minus 1 terms will give us the nth term. Okay. Now let's write down Sn. They've given 2n square minus 3n. Write it down. In place of n, put n minus 1. So minus 2 into n minus 1 the whole square minus 3 into n minus 1. Now you can simplify this. Very simple. Open the bracket. This is a perfect square. Okay, open the brackets and simplify. You will get the value of Tn as 4n minus 5. Now we have to show that this series is an AP. AP means it should have common difference. Let's write down Tn is equal to 4n minus 1, 5. So first term will be, put n is equal to 1. You get minus 1 is the first term. Second term is 3. Put n is equal to 2. Put n is equal to 3. Third term. Fourth term. So here do T2 minus T1. You get 4. T3 minus T2 also is 4. So the common difference is 4. Therefore, the series is an arithmetic progression, AP. And what is the series? This is the first term. Minus 1, 3, 7, 11. Dot, dot. Question 5. The 104th term and the 4th term of an AP are 125 and 0. Find the sum of the first 35 terms. So what have they given? 104th term. That means T 104 is equal to 125. Okay. And this is the general formula of a nth term of an arithmetic progression. Okay, so this is the general term. So here let us substitute n is equal to 104. So 125, T104 is equal to 125. 125 is equal to A we do not know, D also we do not know. So 125 is equal to A plus N, 104. N minus 1 is 103. A plus 103D. So here it is. A plus 103D is equal to 125. This is the first equation. Second equation, T4 is equal to 0 they have given. So here again in this general equation, write down here 0 is equal to A minus N is 4. So 3D. A plus 3D is equal to 0. So from this you get A is equal to minus 3D. Substitute here minus 3D plus 103D is equal to 125. So 100D is equal to 125. D is equal to 5 upon 4. Now we got the value of D. We want to find the value of A. So for A is equal to minus 3 into D, 5 upon 4. So this is minus 15 by 4. A is equal to minus 15 by 4. And in this sum, find the sum of the first 35 terms. So n is equal to 35. So here are the values. D 5 upon 4, A minus 15 by 4, n is equal to 35. Write down the formula, substitute these values, simplify, you will get the answer. Sn is equal to 612.5. Find the sum of all odd positive integers less than 450. So what are those integers? Let's write down. They are given that the sum of odd positive integers less than 450. So first integer is 1 plus odd positive integer. So the next odd integer will be 3. 1 plus 3 plus 5 plus 7 dot dot till 449 less than 450. So 449 is also an odd integer. So this sum they are asking us to find. Now this is very simple. Write down A is equal to 1, D is 2, L the last term is 449. Okay. Here we do not know the number of terms n. So let us first find out n. Use this formula. We'll get the value of n as 225. Now you can use this Sn is equal to n upon 2 A plus L because we know the value of L. So substitute these values, simplify, you will get the answer as 50,625. So here we come to the end of the first 6 sums of this exercise 2.6. The remaining sums of this exercise I have done in the next video. Please go through that also.